I'm going to start today actually by telling you a little bit about myself and about Quantopian in order to give you some context for why I'm talking about women in the S&P 500. I'm a product manager, which means that I work with developers to build software products. And I don't code myself to build our software products, but I work with them to understand the business's needs and figure out what our customers want. And I've been doing this for about 12 years. I have a degree in computer science, but I actually haven't programmed in 12 years, until this past August, when I came to Quantopian. And Quantopian is a platform that's a community of people building algorithms to invest in the market. And so our users program in order to use our software. And as a product manager, one of the most important things I can do is understand what my users do on a day-to-day basis. And so when I started at Quantopian, I knew I was going to have to write an algorithm to invest in the market. And so I thought this would take a week or two, honestly. I thought I'd come up with some idea, share it with the community, get some feedback. I had no idea it was going to take me 6 months to come up with my strategy. And what I'm going to talk about today is the process that I went through to create this algorithm and what I'm going to tell you about my return to coding as well as what I've learned about finance throughout the process. So we will dive right in with that. First, I'm going to tell you about the problem that I decided to look at. In September of last year, Credit Suisse released their Gender 3000 report, which was a report where they looked at 3,000 companies across 40 countries and how gender was represented in the organizations. And it had a lot of really interesting information. It showed that 12.9% of the companies, 12.9% of top management was women across those 3,000 companies, and only 12.7% of the boards had female participation. Those numbers are pretty abysmally low, but I don't think they're actually that surprising if you pay attention to the topic of conversation of women in business. They also had a couple of charts that were really interesting. This one takes a look at the performance of companies who have women on their board, which is the gray line, as compared to those that have no female participation. And so you can see the historical performance is much better if there's at least one woman present on the board of directors. Likewise, this chart takes a look at the percent of female management within the organizations and their historical performance. So the green line here is all companies. The blue line is 25% female participation in the management team. Gray line's 33%, and purple's 50%. And so you start to see that this performance information is really interesting. Unfortunately, Credit Suisse does indicate in their report that the numbers that they're using here remove other companies that might have failed during this time period. So it has what we call survivorship bias, meaning only successful companies are represented here, and any company that failed isn't taken into account. So the numbers, while a great start, they're not perfect. But they did make me wonder, what would happen if you invested in female CEOs? And could I write an algorithm to do exactly that? And so that's what I started to explore. And that is what I'm going to walk you through today. And so I'm doing this within an IPython notebook environment that Quantopian's built within our platform for our customers. And so you'll be able to see both the code that I wrote as well as the results of that code being executed. The first thing I actually needed to do was get the data, which was a little bit harder than you would expect. What I was able to find from a nonprofit called Catalyst was a listing of the historical companies that have been in the Fortune 1000. So every year, back 25 years, it took a look at which companies in the Fortune 1000 had a female CEO, and it listed those out. I knew generally what I wanted to do was take a look at the companies with female CEOs and invest in them while they had a female CEO. So buy at the beginning of the CEO's tenure in the role and sell when she left the position. And so I took this list of the Fortune 1000 companies historically that had female CEOs, and then I went to Google to find the start and end dates of these CEOs. I did a lot of Googling, and then I actually used Mechanical Turk, and I had 2 different people on Mechanical Turk for every company run through and also get the data so that I could validate that the start and end dates were relatively accurate. And then I also got the ticker symbol. And so in this first chunk of code, what I'm doing here is I'm importing my CSV that has the data, and then just printing out a couple of pieces of information about it. And you'll see here the number of CEOs represented was 80. So there are 80 female CEOs. Oh, and I'm sorry, I didn't clarify. The time period I was looking at was the beginning of 2002 through the end of 2014. And the reason is that's the historical pricing data set that I have, covers those years. And so in that time period, there were 80 female CEOs at 74 companies. So a couple companies had multiple female CEOs. And what's interesting is, as I've started to put this information out there and share my algorithm with the world, one of the pieces of feedback I get is, your data set's too small, your sample size isn't big enough. Yes, exactly. 74 companies total, 80 CEOs. So out of the whole sample of Fortune 1000 companies, so it's 1,000 different companies every year, but I don't actually know the number in aggregate. So this is the first 10 rows of my data set, where you can see I've got the CEO, the company name, the ticker symbol, and the start and the end date for that individual CEO. And so I pull this into my notebook as my data set. I wanted to understand how many new CEOs there were per year, just to get a sense of the data. And so I was able to plot that out pretty easily. And so this is new female CEOs each year for the period that I'm looking at. And I was pleasantly surprised that it definitely goes up and to the right, which is great. When I first looked at this, I was a little bit concerned. The market's done really well since 2008 to today. And so I was worried that my algorithm would have some sense of bias because there were a lot of women in the second half of it from 2008 to today. And so my algorithm would look good just because it had been done over this time period. There are still a number of CEOs at the beginning part of the algorithm, my data set. And so I continue to move forward, but that is something that I was considering throughout it. As with any project, the first thing I had to do was scrub the data. And whether or not you're working in Excel or in Python, this is something that you always have to do. And so this first chunk of code here, all that does is get my start dates and my end dates in the right format with the right time zone so that I can use them to compare against the current day. I then had to deal with an issue of trading days. One of the interesting things about the market is you don't trade 365 days a year, right? You only trade on weekdays. And you don't trade on all weekdays. You don't trade on Memorial Day, which is a Monday. You also don't trade on half days, like the day before Thanksgiving, or you do trade on a half day the day before Thanksgiving, but you only trade for half the day. And so there's interesting things that need to be taken into account. And so I spent a bunch of time trying to clean up the dates to make sure that I had weekdays. The other interesting thing here is CEOs aren't like us. They don't start a new job 2 weeks after they quit their last job and then go start the new job on that next Monday. They start on the first of the month or the first of the quarter. These days could be weekends, they can be holidays, but it's generally a calendar-based date, not day of the week. So this code actually takes a look at the number of the day of the week, whether or not it's the 6th is a Saturday and the 7th is a Sunday. So you see here it's if weekday equals 6, that's a Saturday, move it to 2, or move it 2 days, which makes it Monday. And if it's a 7, which is a Sunday, move it 1 day to Monday. Now, I spent a lot of time trying to clean this up and then realizing the problem with some Mondays or holidays, and then going in and manually trying to fix my datas and just cleaning the data. And I was showing this to my CEO at one point, and he says to me, Karen, we have a trading calendar. And I was like, wait, what? And in our platform, we have a calendar that does this for you and tells you if your date's a trading day or not. So this is one of the great reasons to understand why a product manager does things like this, because in order to understand what my users were doing, I was sitting here showing him what a pain dealing with a trading calendar is, and he was like, yes, we already solved that problem. And I haven't updated my notebook to use it yet, and Joe's here in the front row laughing at me because he has volunteered to teach me how to use our trading calendar, and I will get to that in my next version. The next thing I needed to do was deal with the CEO start and end dates. So I had data that went before my pricing data range, which started at the beginning of 2002. So CEOs that started in their role before 2002, but for which, for my purposes, I needed their start date to essentially be January 2nd, 2002, which was the first trading day of 2002. And so this next block of code basically says if your start date's before January 2nd, move it to January 2nd. And it also deals with CEOs who were still CEOs as of the end of 2014. I decided to end my data at the end of 2014 because that's where my female CEO data ended. The report from Catalyst ended at that point. So while there have been new CEOs that have started in 2015, I haven't dealt with that at this point. And then the last thing was dealing with ticker symbols. Did you know ticker symbols are not unique? You can reuse ticker symbols. So if a company with the ticker symbol Q goes out of business, another company can just start using the ticker symbol Q, which basically means when you're dealing with historical data of pricing and stocks, you have to be able to account for the fact that the ticker symbol might be for a different company at different points in your history. So we use something called a security identifier, or SID for short. The other great thing about the finance industry is this hasn't been standardized across data sets. So there is no unique identifier for companies in terms of their ticker symbols and how they're traded on the public market. So we use a SID, and so this code here basically just takes the ticker and the start date. And it says, go and find the unique identifier for this company for this ticker on this start date, which helps me ensure that I'm getting the correct pricing information for my analysis. So at the end, I've got my 80 CEOs, and here's what the data set looks like. And so I've got all the information for them that I need. The next thing I wanted to do is just get a general understanding for how this data looked and what it looked like. So I decided to look at the returns of companies, and I did this very simply. I basically just took the end price and the start price and calculated the percent change over the time period. And that's not a perfect way to do it. You could have stock splits and you could have dividends, all of which affect this, but I just wanted a general sense for how the data looked. And so I've shown here, this is the top one is the top 5 performers with HSN at a 506% change over the periods when that CEO was in the position. And then the bottom performers, poor Janet Robinson with a negative 80% change over her time at the New York Times Company. And so I then had a moment where I was like, my top performers have outperformed much more than my bottom performers. So is this going to be a problem? Because obviously it'll look good and it'll be because the data's skewed. And then I realized nobody lets you stay the CEO of a company if your stock goes down, hundreds of percents, and that doesn't even happen. And so you can't do that. You don't get to stay in the position, so they're moved out. But if your stock goes up 500%, you are not booted from office. So this actually then makes sense. All right, sounds good. The next thing I wanted to do was look at the data one company at a time. And as a product manager, I was doing this within this research environment and using IPython, and one of my key theories was our users would use this to bring in external data, compare it to the pricing data that we provide, and then plot it to look for patterns. And so I said, okay, let me try to do that and understand how a user would do that. And so I wanted to just get the stock price of a company and plot the start and end dates of the CEO on that historical stock price. So here, I use this function, getPricing, which basically gives a start and an end date and my list of SIDs, or my companies, to get me that historical pricing. And then what I'm pulling here is the daily close price for each of these companies for 12 years. There's minute-level data here, but because the actual minute that the CEO becomes the CEO of a company doesn't really matter, I just use the close price for my evaluation. I then identify the security by SID, and I'm just doing this one at a time manually to get a sense. I also wanted to know if, as I'm going through this, could I analyze 80 companies one by one and get a sense for if my algorithm was going to do well. So I ran this, and this is for Yahoo. And you can see that in the 12-year period, Yahoo had 2 female CEOs. Carol Bartz was here. The up arrow indicates a start date, the down arrow indicates an end date, and then Marissa from here to present day. Well, that's interesting. And what this allowed me to do is pretty easily go and change the companies that I was looking at. The only live version of my demo, because live demos are scary. Here we look at Avon Products, and you can see Avon actually has a CEO that starts at the beginning and then switches to another female CEO here. So for the entire 12-year period, Avon had female CEOs. But I was able to pretty easily go through my 80 companies and look at them like this. I learned 2 things. 1, how to plot my stock price data with external data, and 2, there was no way I was going to be able to analyze manually 80 companies and determine if this would be a good investment strategy. So lessons learned, but moving on to something else. I then decided to dive right on into my algo, and here's the concept. What I'm running here is a historical backtest, which essentially means starting at the beginning of 2002, every single day, my algorithm's going to go and basically look at that data set and say, did any CEOs start today? And if they did, it's going to buy. And then it's going to say, did any CEOs end today? And if it did, it's going to sell. And then it'll move on to the next day and ask those same questions. And it's going to continue to move through history, asking this every single day, and then buying and selling at the historical stock price for that company, and keeping track of the returns and the information. For the first version of my algorithm, I just decided to keep this simple. And each day, when I bought, because the CEO started, I bought 500 shares of the company. And then when I ended, I just sold all the shares that I owned. So I was just keeping it very simple. Once I look at that, I wanted to know how many companies was I going to hold each year. And so it starts right off the bat, actually, with 9 companies that were in the Fortune 1000 and had female CEOs at the beginning of 2002. And I buy those on the first day of my algorithm. And then by the end here in 2014, I hold almost 50 CEOs or 50 companies because there are 50 female CEOs at that point in time. So it does grow to a sizable portfolio. What's the y-axis is number of females. The number, it's not number of shares, it's number of companies. Number of companies. So it starts in, and it's in the total year. So in this first year here, which is 2002, there's 12, and at the end, it's almost 50. So then I dive into my algorithm. To do this, what I'm using is Zipline, which is Quantopian's open source backtester. So this is available for anybody to use. And it has 2 key functions. Initialize, which is run before your backtest starts and sets up any global variables, gets everything ready, pulls in your data, that type of stuff. And then handle data. And handle data is what runs every single day to determine if I should buy or sell any positions. And so what this does in handle data, that's where the interesting thing is, it gets today's date right here. And then it says, today, are there any CEOs who start today? Where's my pointer? There it is. Any CEOs who start today, save them. Any CEOs who end today. And then very simply, this first for loop here says, for anybody who started today, go and buy. And you can see there, 500. That's the number of shares to buy. So it's like, go and buy 500 shares for any CEO at the company of any CEO that started today. And then in this next one here, it does the exact same thing where it says, for any CEOs who ended today, go and exit my position in that company. And you'll notice here, what I'm using is a function called order target, which basically says, I want to own 500 shares, do whatever you have to get to that target that I want to own. And likewise, I actually use the same thing down here. My order target's 0 then, which basically says if I own 500 shares, sell it down to 0. So it takes care of all the details around buying and selling for me, but it gets the stock price from that historical data. I then run that, and I get some pink stuff, which I ignore. And here's my chart. And you know what? It goes up and to the right. And I was thrilled at this point. I had written an algorithm, I ran the algorithm, and it went up and to the right. And I actually, at this point, I went home for the day, and I told my husband how excited I was. And I said, female CEOs look like they do great. This is awesome. I'm going to bed. And at 3 a.m., I woke up in the morning, and I was like, oh, I didn't compare it to anything. So it could go up and to the right, but not up and to the right amount. And then I realized I needed to put in a benchmark. So this is all part of the learning process. I come back to work the next day, and I talk to some people, and we decide to go with the S&P 500 as my initial benchmark. Pretty standard benchmark used for these kinds of algorithms. Let's just use that and see how it looks. So I get the data, the historical data for the SPY, which mimics the S&P 500. And what I do for my 12-year back test is at the beginning in 2002, I buy $100,000 of the S&P 500, and I hold it for 12 years, which is a fine first pass. I set that off to run and then plot the 2 algorithms against each other. And I still get a lot of pink stuff, which I continue to ignore. And there it is, the results of my algorithm. My algo is the blue line, the S&P 500 to the green line. I throw my hands up in the air, I declare success, and then I tell my boss I'm quitting and I'm going to become a quant because look at the algorithm I wrote. And then he asks about the leverage. Because apparently the #1 mistake new users make when they write their first investment algorithm is that they don't know what leverage is. And I didn't know what leverage is. Leverage is when you borrow money to invest in your fund, in your idea. And so essentially your broker will lend you money so that you can invest more than you actually have and get greater returns. What was happening here, and all those pink error messages that I was ignoring, there were a lot of them, was basically I was zeroing out my losses and just borrowing more money to invest in my idea that wasn't working. And it wasn't working because of the way that I was buying the 500 shares. So this is what my leverage looked like when I figured out how to plot it. And a leverage of 1 basically means you're not borrowing money to support your algorithm. And here, my leverage, you'll see, is a nice 4,000. So that's not good. So I needed to go back to the drawing board and figure out how to correctly do the buying and selling of my shares. And I spent some time talking with one of the guys on our team, a data scientist who's worked at a hedge fund. He actually started his own hedge fund. And he explained to me that what I needed to do was not invest in a single number of shares or a single dollar amount per company, but I needed to take the number of securities in my portfolio, divide the size of my portfolio by those securities, and then I could just for this pass invest an even amount in each company. And so at the beginning, when I have 9 companies that I'm holding, 1/9 of my portfolio is invested in each of them. And then each time I add another company into the portfolio, I rebalance the entire portfolio. So when I add a 10th company, I then take my portfolio value, divide it by 10, and do 1/10 of the value of my portfolio in each company. And what this does is it ensures that any losses that are incurred are then cashed out, and then the correct balance of my portfolio is reinvested, and it makes sure that I've got an equal amount in each company. Very rational. So I go and I make that happen. And this is one of the times when I was like, okay, I know how to do that. I'm going to go and I'm going to rewrite my code. And I start typing away, and I type away, and I can't get it to run correctly. And I actually had to take a step back and go to the whiteboard and draw out the pseudocode for how I was going to make this work, and then sit down and reprogram it, which is an interesting reminder of how the programming process works. And I don't know what I was doing wrong the first time, but I actually scrapped what I was doing and started from scratch. And one of the keys here, there's a lot that's familiar from the first algo. I still identify the stocks to order today and the stocks to sell today. And if I have stocks to order today or stocks to sell today, I go into the functionality to figure out the buying and selling. But I have the concept of my current stocks. And that's what I keep track of, because I need to know the number of stocks that I'm going to hold, not the number of shares, but the number of companies that I'm going to hold at any given point in time, so I can do the math of getting my portfolio value and dividing by that number and identifying what to put in each company. And so first I sell off any companies. That's what this does. I take the stocks to sell today, and I sell each of them, and I update the current stocks to take into account the fact that I'm removing them from my portfolio. I then update the current stocks with everything I'm planning to buy, so I can get the total number of stocks in my company. And then I go through and I do the buying. And here's the math where I say, what's the current portfolio value? Get my total number of stocks. My value to buy is the portfolio value over the number of stocks. And I use order target value and get the stock, which is the security identifier again, and the value to buy is the amount I'm going to buy. So every time I add a stock to my portfolio or remove a stock from my portfolio, it rebalances every position in the portfolio. Now it doesn't, the beautiful thing about this order target thing is it doesn't sell everything off and then rebuy everything. If I have $10,000 of one company and I actually need $8,000, it knows to just sell $2,000 worth of that company, as opposed to selling everything and rebuying it. So it helps keep the transaction costs in line. So I was a little bit nervous at this point, honestly. Like, it was great when my chart went up and to the right, but I was about to run it, and this was a much more realistic way to do the algorithm and what was going to happen. And without the benchmark, it still went up and to the right. That's good, right? But we know that we need that benchmark. And so the other problem with my first pass that Justin helped me identify was investing $100,000 at the beginning of my time and then holding it throughout the 12 years isn't a really accurate way to do a great benchmark, because there are dividends and there are stock splits and there are all these different things which change the price. And so I wanted a benchmark that had been optimized for what would actually happen if you reinvested over the course of the 12 years. And so within our system, we've built one of those. Again, learning about what we've done to help our users by being a user. And what I just needed to do was import that benchmark, which is what I do here in this line. And so I import that, and then I plot them against each other, and this is the results. My algorithm, which is the green line, still outperforms the S&P 500. And when you do out the math, essentially my algo returns 340% over the 12-year period, which is 217% better than the S&P 500, which I was pretty pleased about. At this point, I was feeling pretty confident in how I did the ordering and what was coming out there. But there were more questions. And actually, at this point, what I did was I took this to our community and I shared it. And I talked to, actually, before I did that, I also calculated the leverage to make sure I wasn't making the same mistake. And the leverage, like I said before, it's about 1 here. In 2008, there are some losses that have to be maintained, but it stays at about 1, and this is a very good leverage that indicates no problems with that. I then took it to the community, and I went down to New York, and we have a meetup there, and I presented it to about 60 quants in New York and got their feedback on it, and the feedback I got there was really exceptional. And one of the things they talked about was a Sharpe ratio. Sharpe ratio is how you calculate volatility. And so if you're investing in these algorithms, you can create an algorithm that's incredibly volatile, which means more risky and carries more risk. And so I wanted to calculate the Sharpe ratio, which again is something that is easily done in the system, and high numbers are better. So my Sharpe ratio is 0.6 for this algo, and the Sharpe ratio of the S&P 500 over the same time period is 0.2. 0.6 isn't like a standout Sharpe ratio. It's good, it's not great. It beats the S&P 500, which is awesome, but it's people talk about it, and people get really excited about Sharpe ratios that are 2 or 3. So while this is better than the S&P 500, it's not, a blow-away stock algo when it comes to volatility. So I got a lot of interesting questions when I shared this. I shared it at the meetup. We shared it in our community. I put this entire notebook, so all this code's actually available if anybody's interested in exploring this further, out to our community, and it got picked up on Hacker News, which was really interesting, and there's a lot of discussion there. And I'll tell you, before I shared this, I was a little bit terrified. I consider the female in business topic to be like a third rail. You can blow up in your face if you put this kind of stuff on the internet. And I'll tell you, when I shared this, the Hacker News community was incredibly receptive and supportive. I got a lot of really good feedback on ways to evaluate it and ways to think about it further, and no attacks at all, which I thought was really wonderful. But one of the questions I got was, well, isn't this just Yahoo? Because what happened was Yahoo made an investment in a little company called Alibaba. And Alibaba IPO'd, and Alibaba did very well. And you'll notice Yahoo's stock, this is when Marissa Mayer started, and this is where it is today, or at the end of 2014. And a lot of this has to do with Alibaba. And so the question was, well, isn't this just that you're capitalizing on the returns of this one event that's making your algorithm really good? The beautiful thing is it's really easy to test that. So I basically, just with one line of code, can remove Yahoo from my algorithm and run it again. And when you do that, the female CEOs of the Fortune 1000 still outperform the S&P 500 to a tune of 197% better than the S&P 500. And the reason is actually pretty interesting. Remember that chart I showed you at the beginning that was the number of positions I held at any point in time during my algo? Well, towards the end of my algorithm, in the years when Marissa Mayer's the CEO of Yahoo, it's like 1/45th of my portfolio. It's just not a big enough position that it has a huge impact. Sure, it has about a 20% impact. It's not that it has no impact at all. It is a good position in the portfolio, but it definitely isn't enough to make the entire outperformance here due to that. The next thing that was a really good question that I got was, well, what if you remove the outliers? Maybe you just have a couple of top performers, and they're the ones carrying the entire performance of the algorithm. So I pull out the 3 top performers, but to be even, we're also going to pull out the 3 bottom performers and look at what the algo looks like with that. Once I do that and rerun the portfolio, it again changes the returns. Female CEOs still outperform the S&P 500 to a tune of 145%. So the female CEO algo is 145% better than the S&P 500 when we do this, which is a really interesting way to look at it. The last thing that I've taken a look at is the sector base of this portfolio. Now, I'm working from a data set that has 80 companies in it, and it's really because getting CEO gender information is actually quite challenging, especially historically. And so I'm sort of working with the data that I've got. When you take that Fortune 1000 companies and you split it out by gender, what you end up with, I'm using Morningstar sector information here. They identify 11 different sectors. And you'll see that this sector here, which is consumer cyclical, is pretty significant. The one next to it is consumer defensive. Those two combined represent about 30% of the portfolio. So 30% of my portfolio is in consumer companies. So the argument you could make here if you're questioning this is, well, it's not actually the CEOs. It's the fact that you are benefiting from an outperformance in the consumer sector. So the first thing I did was take a look for some kind of comparable. There's XLY, which is a consumer discretionary ETF. And so I just plotted the XLY against the S&P 500 to see how did the consumer sector do over this time period. And XLY, the consumer discretionary ETF, does outperform the S&P 500 over the same time period. It's not as significant as my portfolio, but there still is an outperformance there. So then, and actually I did this past week. This has been something I've been planning on doing for a while, but I wanted to bring something new to show you all. And so what I did was a sector neutral strategy. And I spent a bunch of time talking to Jess, who's our head of quants at Quantopian, and she talked to me about not changing the benchmark that I was comparing it to match the sectors of my portfolio, but instead neutralizing the sectors. And what the new version of this algorithm does is it takes those 11 sectors and it looks at my portfolio at any time, and it says how many sectors is the portfolio in today. It then divides the portfolio evenly between those sectors. So let's say there are 3 sectors at the beginning of the time period. It divides the portfolio in 3, so each sector gets 1/3 of my portfolio value. And then within the sector, no matter how many companies are there, it divides the amount allocated to that sector by those companies. So what that means is you could have a sector that has 3 companies in it that each get 1/3 of the amount allocated to that sector, which is 1/3 of the overall portfolio. And you could have another sector that has 10 companies in it, so they each get 1/10 of the amount allocated to the sector, which is 1/3 of the portfolio. So the companies end up having different amounts based on the sector that they're in. And the idea here is to make sure that every sector ends up having the same amount invested in it. And what that will do is even out this bias here by the fact that 30% of the companies within my portfolio are in the consumer space. And so at the end of this, what we're trying to see is, am I really just investing in the consumer space here, and my outperformance is due to it being a part of the consumer space? Make sense? So the code gets a little interesting here, and essentially the fun stuff is down here where I'm looking at, I get the portfolio value, I get the number of sectors, I get the value per sector, which is the portfolio value over the number of sectors. I then, down here, get the current company sector and the number of companies in the sector. And then when I figure out the value to buy, it's the value per sector over the number of companies in that sector. And so there's a whole bunch of division that has to happen there, but to get to the amount that I'm going to invest in this particular company, and again, every time I add a company to my portfolio or remove a company from my portfolio, I'm rebalancing using this approach. So the number changes of what I'm doing into that. So when I run this, here we go. The female CEO's algorithm, green, still outperforms the S&P 500 when it's sector neutral. The returns are 153% better than the S&P 500. So what this shows is that it's not just that we're investing in the consumer market, that's not what the outperformance is due to. None of this tells us what the outperformance is due to. And I make no claims about causation, correlation, and all of that. All I'm doing here is showing a whole bunch of different data around how I've evaluated this algorithm. So at this point, you get to the question, well, I get to the question of, this looks like a pretty interesting algorithm. Should I quit my job as a product manager and become a quant? Am I really the first person to think about this? And the answer is, of course, no. There are at least 2 that I can get the data for, existing funds with a gender focus, and I've been told that there are 17 products out there right now that are focusing on the disparity in gender in organizations. The 2 here are the PACs, which is the blue line, and the Women in Leadership Fund, PAC's Elevate Fund and the Women in Leadership Fund. And over the period that we have data for those 2 companies, because they haven't, 2 funds, they haven't been around all that long, they are both underperforming the S&P 500. And so I don't know how they're doing their selection exactly. I do know the PAC's fund also includes international companies. It's a much broader base that they're picking from, and so that has a difference. The Women in Leadership, it's companies with $250 in market cap or more, a female CEO, or 25% of their board is women. So they're using different metrics in order to pick the companies that they're investing in. I've talked to a portfolio manager at PAC's, and we've discussed the challenge of getting gender data. I've actually talked to 3 different people that are doing products that invest in females, and all of us, the biggest problem is finding out whether or not a CEO is a woman or not, and knowing if you can make that investment. And so this is really interesting to know that other people are investing in this. I'm going to switch back really quick to my presentation. So this is all fascinating, but what are the next steps? Academically, there's a lot of cool stuff that can be continued to research based on the work that I've done. Looking at it from a market cap neutral strategy would be really interesting. All of my companies are the Fortune 1000, so they're relatively large companies. Generally, when you're writing investment algorithms, you're trying to remove the smaller companies, so that's good, but it could be a bit biased towards larger companies. It absolutely is biased towards larger companies. I would love to get a broader data set, and I actually am talking with 2 different vendors who do have data, who do have gender within their data set to try and get a broader data set with more companies to be able to evaluate on that. Professionally, I'm a product manager, and so what I want to understand is if I'm a quant and I have this algo that I think looks pretty good, what do I do with it next? And on Quantopian, one of the things you can do is live trade your algorithm. And so you connect it to your broker, and then you can live trade real money. And that's actually where I'm headed. That's going to require that I get a data source that updates in a near real-time basis when companies add a female CEO so that I can make that investment. But based on the analysis I've done, I feel pretty confident that this is worth putting some money into and seeing how it performs in the future. And so I'm working towards that, again, so I can understand what my user would do. And I'll tell you, in the 4 or 5 months since I've put this out there, the biggest challenge is getting data that I can use to make it live trade, which is an interesting challenge for our users that it's good for me to understand. But aspirationally, my goals for this are a little bit different. Quantopian's at a really interesting intersection of the worlds of finance and technology, which are 2 industries that are woefully lacking in female participation. And what we want to do as an organization is use our community of 40,000 quants who are writing algorithms to invest in the market to create a hedge fund and invest in the best algorithms within our community. And one of the reasons we think that's a good idea is because by opening up these tools to allow you to write algorithms to invest in the market to the world, we're able to access a much more diverse base of people to write algorithms to invest in the market. And we're actually doing really well in a lot of ways. We have 50% of our users are international. So we're accessing a lot of talent outside of the United States to invest in the market. The other thing is our users aren't all finance people. So you have 10,000 quants in the world that work at hedge funds. Obviously, they're all finance people. It's a rather small community. And so if you access people outside of that world, you're going to come up with new ideas to invest in the market that will hopefully have different approaches. And our users are mechanical engineers, they're computer scientists, they're physicists, they're PhDs, they're data scientists. It's a really broad range of people, and the majority of them are not in the world of finance. So hopefully that will allow us to get really interesting new ideas. But we do not have diversity of gender. I estimate that less than 5% of our community is women. And we're really focused on this as an organization, and every time a female comes to our community and shares something, we get really excited. We're like, there's a woman in our community or at our meetups. It's something that we are really thrilled to see. And I hope that by getting up here and standing at different conferences and sharing my work, and the fact that I haven't programmed in 12 years, and that I'm not a quant, but that I'm able to create an algorithm with pretty decent returns, I'll inspire other women to start doing the same thing and to join the Quantopian community. Thank you very much.